Hi Trotters friends, I am so excited. Today we're going to be making something that I love to play with at Little Trotters, and it is called kinetic sand. So if you go to the beach, you might pick up sand, but the sand will run through your fingers. Unless you add water, it doesn't stick together. So today we're going to use things that we have in our kitchen at home to make something really fun to play with, but it would not work if we did not use science. Alrighty, so we're going to start with some flour, and then we're going to use a little bit of oil, and we're going to mix them together and see what happens. So flour is a dry mixture, which means that the moisture has actually evaporated out of it or was never in it in the first place. Look at this. So this is a dry mixture. If you notice, when I pour it into the bowl, it's really loose, and the different particles of the flour do not clump together. When I use my hands, they just fall apart. That is a dry mixture. Now I just used a 1 cup measuring cup. I put 1 cup of dry flour in one bowl, and I'm going to take another cup of dry flour and I'm going to put it in a second bowl. So 1 cup in one bowl and 1 cup in a second bowl. At the moment, these two mixtures are actually, these two substances are exactly the same. But we are going to see the difference between just the ordinary flour and then when we magically use science to turn the flour into kinetic sand. What is kinetic sand? Kinetic sand is a special type of sand that has polymer chains mixed with the sand so that the sand can stick together. Where are we going to find polymer chains? Well, we're going to use our oil. Our oil is a viscous liquid. It's not as thin as water. It's actually more viscous, and we're going to just pour a little bit of oil into our bowl. And then we're going to get a tablespoon. Do you remember a tablespoon is a pretty big spoon? And we are going to carefully take 1 tablespoon of the oil, which is a thick, viscous substance, and we are going to pour it onto the flour. I'm so excited. I cannot wait to see what happens. So we're going to take a fork. A fork works really good because there's different spaces in between the prongs of the fork that allow the flour to mix really well together with the oil. And we are going to just mix it. I'm just going to show you right here. You have to be pretty patient, and you've got to do a really good job of mixing. I bet you are great helpers at home, and you would be really good at mixing. This is a fun project to do. So I noticed that the texture is the feeling of the flour is starting to change. Something is happening. It is science. Oh, let's keep going. Okay, I think that I have mixed all of the oil into the flour. It's a little bit different, but I think I need another tablespoon of oil. So I'm going to take another tablespoon of my viscous oil. It's a liquid, a thick liquid, and I am going to pour it, see what happens. So we're going to take a fork. A fork works really good because there's different spaces in between the prongs of the fork that allow the flour to mix really well together with the oil. And we are going to just mix it. I'm just going to show you right here. You have to be pretty patient, and you've got to do a really good job of mixing. I bet you are great helpers at home, and you would be really good at mixing. This is a fun project to do. So I noticed that the texture is the feeling of the flour is starting to change. Something is happening. It is science. Oh, let's keep going. Okay, I think that I have mixed all of the oil into the flour. It's a little bit different, but I think I need another tablespoon of oil. So I'm gonna take another tablespoon of my viscous oil. It's a liquid, a thick liquid, and I am going to pour it onto the dry flour, and I'm gonna mix again. Changes are happening. Let's see. Something is happening to this flour. It definitely looks a bit different. Can you see that the particles of flour are actually beginning to bind? They're beginning to stick together. Okay, I'm gonna feel it to see if it feels like kinetic sand yet. I'll know it's perfect when I can hold it in my hand and it takes the shape of my hand. Oh boy, let me see if I can do that again. I'm gonna hold it in my hand and squeeze real tight. Do you think it's gonna take the shape of my hand? Can you see my fingerprints? That is so amazing. Let's look at the difference between these two substances. So this was the ordinary flour before we added the viscous oil. Let's pour it out onto our pan and see what the consistency is. Look at that. As you play with that, oh, it feels so nice. It's powdery, and all of the particles of the flour just actually fall away when you pick it up with your hands. But now we've added the oil, and the polymer chains in the oil are sticking the flour particles together, just like this. If these are the different particles of flour in the oil, in the flour, there's the flour particles. There they are. Do you see how they are very loose? Watch what happens when we add the oil. This is very fun. Little polymer chains stick the particles of flour together so that they don't come apart. Would you like to see what the kinetic sand looks like on the train? Okay. Hang on a minute. Let's see. I'm so excited. Okay, let's see if it's different. Look it doesn't fall away like the other flour. I can hold on to it. I can actually make a ball out of it. And do you know that you can play around with making kinetic sand? If you want it to even stick together and you want the particles to bind together even more with the polymer chains, you could add another bit of oil. This was a bit of a fun and messy science experiment. I hope you have fun at home learning all about polymer chains and how without science we could not make so many amazing things. I think I'm going to spend some time playing with my kinetic sand. Have fun, everybody. Bye.